Flash. Continue joining. I can see you. Continue joining the lesson. We're going to handle the question together. Remember, I had promised to solve this number 16. Under an enlargement, the image of points A, 3, 1, and B, 1, 2, are A prime, 3, 7, and B prime, 7, 5. Find the center and scale factor of enlargement. Find the center and scale factor of enlargement. So this is what we're going to be solving the next few minutes. I can see you are still joining. Continue joining the lesson. Yes, so we can look at the question now. We can look at the question together. I read it once again. Under an enlargement, the image of the points A, which is 3, 7, 3, 1, sorry, and B, 1, 7 are A prime, 3, 7, and B prime, 7, 5. Those are the coordinates and their images. Find the center and the scale factor of enlargement. Before we go to the application of this question, I want to simplify the question for you so that when I'll be solving now, at least you can understand. I can see people are already reacting. I can see Mary Wamaitha saying, "Hi teacher, I'm happy to join today." Welcome so much. Remember to invite friends. Just click the share button and share this link with friends. So I'm going to attend to the question. I want to show you that in an enlargement, which is a type of a transformation studied in book 2 mathematics, We know that for us to have an enlargement, we should connect A to the center of enlargement. Then we prolong it to the other side where we obtain our A prime. That is the basic enlargement. The basic enlargement. We also connect B to the center of enlargement and we prolong it until we reach where B prime is. That is basically how we enlarge. Therefore, I'm going to simplify this information on a graphical page so that you may see the points and their image, how they are. But remember, we've not been told to solve using graphical method. I just want to simplify the concept for you. Therefore, A is 3, 1. So point A is 3, 1. This is where point A is. Then A prime is 3, 7. 3, 7. Therefore, I will plot 3, 7. Yes, this is A prime. Therefore, we got this line. We got this line. We have line A prime. Yeah, this is a line. This is a line A prime. A prime. So we will have line A prime. Then there is a line B prime. B is a 1, 2. B is 1, 2. Therefore, we're going to have 1, 2. This is our B. Then B prime is 7, 5. 7, 5. This point is 7, 5. Sorry, 7, 5. This is B prime. This is B prime. So I'm going to draw it. B prime. Yeah, this is B prime. Therefore, we have 2 points. We have 2 lines which are meeting at a point, and the point is 3, 3. Therefore, at point 3, 3, we have the line A prime and B prime intersecting. So the intersection should give us what we call the center of enlargement. Therefore, it has to be noted now that we are moving from A to the center. Then we move to the opposite side some given number of dimensions until we arrive where A prime is. And that should tell us, because from A to the center then to A prime, we are going to the opposite side. In other words, A and A prime are in opposite sides of the center of enlargement. Then it means that the scale factor is negative. So first of all, we are already having the center according to this graph. The center of enlargement is coordinate 3, 3. That is the center of enlargement. And again, we can find what we call the scale factor of enlargement, whereby now we will confirm what is the length, or what is the relationship between the length of A to the center, then from the center to the A prime. So we can see we have only 2 units to the center, but from the center to A prime, we are having 4 units. Therefore, the length here is 2 times. Therefore, the scale factor is -2, because we are moving 2 times in the opposite direction. If they were on the same side of the center, then we could be having a positive scale factor. But now that it is on the other side, it is a negative scale factor. I can see people are still reacting. I appreciate your work a lot, teacher. Happy to attend your lesson today. Welcome so much. Continue inviting friends. Therefore, what we're going to work out now is to solve now, because anyway, the examiner did not provide a graphical page. That means we should work it out using other mechanisms and not using a graphical page. But at least the graphical work is able to help us outline. It is able to help us know whatever is happening So we have two lines intersecting. They give us the center. And after giving us the center, now we can obtain the scale factor, which we first of all conclude that it is negative due to the fact that B and B prime are on opposite sides of the center. A and A prime are on opposite sides of the center of enlargement. Therefore, now, basically, we have known that at least with A and A prime, B and B prime, they will act as 2 points of given straight lines. Then we know that the two lines are intersecting somewhere. Therefore, we're going to have a line A prime, and another line B prime. Then now we look at the point of intersection of these two lines. We work out the point of intersection of A prime, B prime. That is what will give us the point of intersection. Graphically, we've already seen that it is the coordinate 3, 3. We want to see whether it will be so when we work out mathematically now. We can use the concept of straight lines and gradients, and we also consider what we call the intersection of two lines. Therefore, we're going to have A prime being 3, 1 and 3, 7. Therefore, we can get the first gradient by taking 7 minus 1, that is the change in y, divided by 3 minus 3. So this is going to be 6 out of 0. 6 divided by 0 will be infinite. We cannot divide. Therefore, we will leave it unsimplified. Then we can get now the equation for the first line, whereby the gradient 6 out of 0 is given by, we take one of the coordinates A, then we let another coordinate to be xy, so that we may get this equation. So it will be y minus 1 out of x minus 3, considering this coordinate. So now we're going to have a cross multiplication. The y and 1 becomes 0 because of this 0. Then 6x minus 18 equals to 0. So that we get now the value of x as 3. So this is the first equation for the first line, which is A prime. The second line, we get also the gradient. Remember, the line now is B prime, whereby we have 1, 2, and 7, 5. So you can take 5 minus 2. Now for the other line, gradient 2, we need to get 5 minus 2 out of 7 minus 1. 7 minus 1. Therefore, we're going to have 3 out of 6. This simplifies to half. Therefore, the gradient is half. This is to mean that now we will have half as the gradient being equal to, we take a coordinate B, and we let another coordinate to be xy, so that we may make the equation of this straight line. So y minus 2 out of x minus 1. Yeah, x minus 1. Then now we can cross multiply. This will give us 2y minus 4, because 2 is multiplying everything here. Then 1 is multiplying x and negative 1 for them to remain just as they are. 2y equals to x minus, when 4 comes to this side, it will be added. So minus 3 plus 4, it becomes positive 3. Minus 4 becomes positive 4, and we have a negative 1. So it will be plus 3. Then now, this will be y equals to half x plus 3 out of 2. This is the second equation for the line B, B prime. Therefore, the first equation is x equals to 3. The second equation is y equals to half x plus 3 out of 2. Therefore, now, with two equations, we need to get the point of intersection whereby we solve the two equations simultaneously. So for us to solve the two equations simultaneously, this now means we will have to substitute the value of x in equation 1 in the second equation, whereby we shall have y being equal to half the value of x, which is 3, plus 3 out of 2. So you find we have 3 out of 2 giving us 1.5 and 3 out of 2 giving us 1.5. Therefore, the value of y is going to be 3. Therefore, solving the second equation, the first equation simultaneously, now we're going to have the value of y as 3 and that of x, which is already 3. They will give us the point of intersection. That will be 3, 3. Therefore, the center of enlargement is coordinate 3, 3. The center of enlargement is coordinate 3, 3. Now, ideally, we are having two lines here. We're having two lines here. Ideally, we're having two lines. The two lines are intersect at point 3, 3. Then this line, which is B prime, is line is having 1, 2, the coordinate 1, 2, and this one is having the coordinate 7, 5. Yeah, 7, 5. Then the other one, whereby we have A is going to be 3, 1, and B, A prime, that is going to be 3, 7. Therefore, we have now an ideal now situation whereby A prime, B prime are intersecting at 3, 3. Therefore, now ours is to know now the scale factor now of enlargement, the scale factor of enlargement. And therefore, we're going to compare two things. People are still joining. And commenting. I can see people saying, I'm happy to attend your live lesson today. I appreciate you, sir, for uploading this video. Welcome so much. Continue following. Now we can see that there is a point of intersection at least, and the coordinates given. Therefore, the next thing I'm going now to use a vector 1 concept, whereby I will need to know the relationship between this vector now from here to the center, then from the center to the point A prime. So we can have the center as C, so that we may talk of a vector AC, then CA. So let us look at vector AC. Vector AC. For us to know vector AC, we need C minus A. Therefore, we need 3, 3 minus A, which is 3, 1. And this will give us 0 and 2. 0 and 2. Then the other vector from AC, we have CA. Vector CA. CA is going to be CA prime, sorry. So A prime is 3, 7 minus C, which is 3, 3. So at this point, we will have again 0, and this is going to be 4. Yes. So it's upon us now to know how the two vectors are related. Vector AC, that is from A to the center, then CA prime from C, which is the center, to A prime, the image of A. Therefore, we're going to express them now in terms of scalar multiples. So we're going to use a certain scalar, let's call it A, for example, multiplied by AC to see whether it will give us C A prime. Therefore, we will be having k, this is 0, 2 equals to 0, 4. Therefore, you can see from the x components, we cannot get what we really want. But according to the y component, the value of k equals to 2. The value of k equals to 2 because 2k equals to 4. Therefore, we multiply the length AC by 2 for us to get CA prime. That means from the center, the distance here is 2 times. The distance is 2 times. 2 times. So that means we will have the scale factor as positive, as negative 2. Negative in the sense that it is on the other side of the center. Negative in the sense that it is on the other side. Now we can, okay, we can use the other line here, B to C, then C to B prime, so that you may get the same concept. So let us begin by saying we need vector BC, that is from B to the center, so that you may take C minus B, 3, 3, minus B, which is 1, 2. This gives us a 2. Yeah, that's a 2. Then we will have 1, vector to 1. The next is going to be from C to B prime, whereby we need B prime, 7, 5, and we subtract C, center, 3, 3. This is going to be, this will be 4, and this will be 2. Therefore, now we can see whether the two vectors are interrelated. So we need vector BC to be multiplied by a certain scalar, call it K, to give us B, CB prime. Therefore, we will have 2, 1 multiplied by K to be equal to 4, 2. Therefore, when we take 2K equals to 4, we conclude that the value of K is 2. When we take again K, according to the Y component, we're going to have also K being equal to 2. Therefore, the length is twice. This length is twice the first length from BC, then CB prime. The length here is twice this one. Therefore, we can conclude that the scale factor is going to be negative 2. Negative in the sense that B and B prime are on opposite sides of the center of enlargement. We can proceed with one more question before we leave the live broadcast. We can have one more lesson, one more question that is, and this one is going to be from equations of a straight line. So I'm going to discuss a few concepts here. We are told in number 17. Remember, session 2 is optional. We just have to get your best 5 questions. Number 17, a straight line passes through P, which is negative 1, 1, and Q, 3, 4. P and Q. Then we are told in the first case to find the length PQ. So for us to get the length PQ, we need the vector PQ first, and we will need Q minus P. That means we will need coordinate 3, 4, and we subtract negative 1, 1. This is the coordinates of P in column form, the coordinates of Q in column form. So PQ is Q minus P. We express the coordinates in column form. This will be 4, because 3 minus negative 1 becomes a positive 1. Then 4 minus 1 becomes a 3. For 3. So with this now, we can get what we call the magnitude, expressed like this. So the length is also called the magnitude, the modulus of a vector. We need the x component squared plus the y component squared. Then we take the square root. So this is going to be 16 plus 9 giving us 25. The square root of 25 giving us 5 units. 5 units. Therefore, the length is 5 units. The next, we are told to find the equation of the perpendicular bisector. So the concept here, perpendicular bisector of PQ, leaving the answer in the form y equals to mx plus c. Find the equation of the perpendicular bisector. Perpendicular bisector, it should be noted that the line now whose equation is being found passes at the mid of PQ. So the mid of PQM, midpoint is usually given by the first x plus the second x out of 2, the first y plus the next y out of 2. We express it as a coordinate. Therefore, we need for PQ where this line passes, because the coordinates of P and Q are -1, 3. So the first x is -1. We add 3, which is the other x, and we divide by 2. Then the first y is 1 plus the second y over 2. Therefore, the coordinate of the point of intersection is going to be positive 2 out of 2, which is 1. This is going to be 5 out of 2, which is 2.5. So this is the point of intersection. Not the point of intersection, but the midpoint of PQ. That is the point where the perpendicular bisector passes. Now, there is something else we should know. We need to get gradient 1, gradient of PQ. So the gradient of PQ will be given by change in y out of change in x. Change in y is going to be, we can take 4 minus 1, because the coordinates of P and Q are here. So we need 4 minus 1 out of 3 minus -1. So this will be 3 out of 4, because this becomes a positive. So the gradient is 3/4. The gradient is 3/4. Something else which has to be noted is that now we are working out the equation of the perpendicular bisector, which passes here, and now the gradient has to be known. Therefore, gradient 2 should be noted that it is -4 out of 3, because gradient 1 and 2 should be multiplied to give us a -1. The gradient of two perpendicular lines should give us -1. Now that gradient 1 is known, the other gradient is automatically the reciprocal with the reverse of the sign. Now this is positive, gradient 2 will be negative, and the quantity will be the reciprocal, 4 out of 3. Therefore now, -4 out of 3 is given by, we let our coordinate xy, and now the coordinate where the line passes, 1, 2.5. Therefore, we'll have y minus 2.5 out of x minus 1. We cross multiply. This will be 3y minus 2.5 by 3 gives us 7.5. Yeah, minus 7.5 equals to -4x positive 4 when we cross multiply with the 4 here. -4x, but this now becomes a positive. So we can now group like terms or rearrange the equation. Equals to -4x. 4 plus 7.5 becomes 11.5. 11.5. Therefore, now we can divide through by y, by 3 to remain with y here, because the format should be y equals to mx plus c. Therefore, this is equal to -4 out of 3x plus, when we divide 11.5 by 3, I'm getting 3 and 5 out of 6. 3 and 5 out of 6. So that is the equation in the desired format. The equation in the desired format. We can go to the last part of this question. We are told to determine the equation of the line parallel to PQ and passes through point 2, 3, leaving your answer in double intercept form. Hence, state the y-intercept. I said, and I'll repeat again, that an examination is a set of instructions. We are determining the equation of a line, which is 1 parallel to line PQ, and the line passes through point 2, 3. And again, we're going to leave our answer in double intercept form. And again, we're going to state the y-intercept. So we have all those instructions to obey in part C. Now that we are talking of parallel lines, it should be known that for a parallel line, the first gradient should be equal to the next gradient. So the gradient of PQ, which had already been obtained as 3/4, should also be the gradient for this other line. Parallel lines will have equal gradients. Parallel lines will have equal gradients. So now we have the gradient and a point where the line passes. So we need another point xy. We need another point xy, another point xy. Therefore, 3 out of 4 equals to change in y minus 3 out of x minus 2. We can now cross multiply. This will give us 4y minus 12 equals to 3x, 3x minus 6. Yes. So for us to express an equation in double intercept form, it should be known that the double intercept form generally equals to 1, is expressed as 1 equals to a out of x and b out of y, and b out of y, b out of y. Sorry, not b out of y, but yeah, generally we have the other factors on the other side. The other factors on the other side. Let's first of all continue. So we will have now, we can begin with 3x. Yeah, 3x. Or why don't we begin with the constants? Negative 12, and this is negative 6, which becomes positive here. So we will have negative 6, yeah, equals to 3x. Equals to 3x. Then now minus 4y. Minus 4y. Yes. So now to remain with 1, because 1 has to remain here anyway, for it to be double intercept form, we will divide through by negative 6. That means this becomes 3 out of negative 6 x minus 4 out of negative 6 y. This is actually the double intercept form of this equation. So generally, double intercept form is not this. Double intercept form is usually given as 1 equals to x out of a plus y out of b. And with this format of an equation, we should know that the value of a equals to x-intercept. The value of b equals to the y-intercept. So now with this equation, the way it is, for us to get y-intercept, we just need the reciprocal of the coefficient of y. The reciprocal of the coefficient of y. So we need to say that this is negative 4 out of negative 6, giving us a 2 out of 3, which means the y-intercept is going to be 3 out of 2 or rather 1.5. If the x-intercept was desired by the examiner, if the x-intercept was desired, we could have gotten it as the reciprocal of x, the reciprocal of the intercept, the reciprocal of the coefficient of x. That means 3 out of -6, giving us -1 out of 2, which means now -2. The reciprocal of the coefficient of x in this format. The reciprocal of the coefficient of x. So that is how we work out whatever we call the double intercept form. The double intercept form. Thank you for following. Subscribe and share.